Welcome back to Best IT Academy's YouTube channel. Let's continue with the topic bulleting data structures. Part 2.
Welcome back. In the last video, we explored a Python list, what they are and how they work, and when to use them. Now, let's move on to another important built-in data structure in Python, which is tuples. Let me write it down here, which are actually tuples. Tuples are similar to list in many ways, but they come with a unique characteristics that makes them particularly useful for certain scenarios. Let's actually dive in. Sorry, a tuple is an ordered collection of items, just like list. Now, lists are created using square braces, right? And you can have bunch of elements which are comma separated. And tuples are also similar to list in many ways. There, however, there is a one key differences that is, tuples are immutable. Immutable. Okay. What does immutable means? This means that once a tuple is created, you cannot change its contents, add any elements, or you cannot remove elements or modify elements there. Why would we use an immutable data structures, you might ask? Now, see, in list, you can add more elements. There are some methods like append, extend, you can also remove using remove and pop. We have certain methods which we can use to modify the list there, but tuple is different. Tuple is an immutable data type. List is actually called as a mutable data type. Mutable means which can be changeable. You can add, modify, do a lot of different operations there, but in immutable data type you cannot add, remove or modify any elements there. Now the next thing is, you might ask, when do we use immutable data structures there? Imagine that you are working with data that should not be changed accidentally during the program's execution. Like you have some kind of points, like some latitude and longitude of some locations. You don't want to accidentally change them. That's one scenario where you can use pull them. Now you want to have some kind of configuration settings which you don't want to change. That's when you can use Apple there. Why would we use an immutable data structure? So that is one example there. Let me also just show you how we can actually create a tuple and the difference between them there. See, lists are created using square braces, where let's say you have an apple, like I'm just storing some elements like some fruits, mango. Now, this is how you create a list. But in tuples are created using, oh, these are not students, these are actually fruits. Now, so here, let's call it as F. A tuple is created using parentheses. And here, similar to your list, you add values. Banana and mango. This is how you actually create a list there. Sorry, tuple there. Now, you can also check the type of the data you have in that variable using the built-in keyword called a type. For example, I can say type of fruits, and here I can say type of F. What do you have? Now, if I execute this code now, you can see the first print statement is printing class list, and the second print statement is printing class tuple. So it is printing out the type of data you have in that specific variable there. Okay, tuples are great when you want to protect the data from being accidentally modified. It also kind of improves performance in certain cases, as tuples are generally faster than list because you because of their immutability there, because Python don't even need to worry about shifting indexes when you add elements in between, or if you add more elements. There is no concerns like this, similar to when you compare with list there. So that is one example I can say. Now, uh, next thing, accessing elements. See, as I already told you that tuples you cannot modify or change any elements, but you can able to access some elements from the tuple then. How do I access it? Using the indexes as well there. In list, we do have indexes where indexes starts from left to right, that too from 0. Now, similarly, tuples also have indexes there. Now, if you want to access an element, you can simply use the indexes values there. See, let's say f of, and you can use square braces and you can provide the index number there. So let me also write it. Variable name, let's say f, and within this square braces, you provide the index. Now, let's say I'm trying to access index value 0. Now, what value or what element do you have at index value 0? Which is apple there. So it actually prints apple there. See, that is one example you can say. Let's also look at a particular example. Suppose you are developing a program to track GPS coordinates. Since coordinates shouldn't change, a tuple is a perfect data structure for this there. Now, let's say we can create a location with certain values like latitudes and longitudes, 47, 28. I'm just writing some random latitude and longitude coordinates, something like this. Uh, Now, if I ever want to print it, I can simply say I'm going to use this f strings. Let's say latitude is location. Let's say location and index value 0. The first value which is at index value 0 is latitude, and longitude you have. Let's say you have it index value 1. So this is how you can actually use it then. Okay. Notice how the data is neatly stored in tuple, right? Ensuring it also ensures that it remains unchanged throughout the program. That's one thing. Now, if I execute this program, you can actually see this particular thing there. Now, uh, fine, we can able to do different we can able to access these things, but what are the different methods a tuple might have there? See, in our last video, in list video, where when I was explaining list, I talked about a particular keyword called dir. Dir is keyword is a method which you can use to get the list of methods or functionalities a specific data type has. One example, let's say, let's try with this f there where you have tuple. Now, if I execute this one, you can see. So sorry, it's not printing. It's not type. Sorry, it's dir. Okay. Now, if I execute this, here you can see it's printing a lot of values there. Now, here each value, ignore the values which have underscores there. Only focus on the methods which don't have underscores, like count and index. So tuple have only two methods, which is count and index. Okay, nowhere they are going to change our tuple data. They are just basically used to count the number of elements, like number of times a specific element is repeated in the tuple, and a particular function called index to get the index of a specific element there. Let's actually experiment with this there. See, let me comment out this one, and let's say print out uh, f of count. I want to count how many times the orange is repeated there, and I also want to. Oh, so first let's execute this. See, 0. Orange is repeated 0. There is no orange at all. Now, if I try to, let's say, count apple, you can see apple is only repeated one time. So it's going to give you 1. See, here you are going to get 1 there. Now, what about the index method there? I can simply say f dot index and index of orange or apple, for example. If I execute this, see, you're getting 0. Apple index is 0. Similarly, let's try to get the index of mango. Now, index of mango, you can see it is 2. If I execute this, you are getting 2 there. What if I try to access a index of index of something which doesn't exist? Let's say I want to get the index of orange. We don't have orange in there. If I execute this, see, you are presented with a specific error. It's just telling that it's a value error. The tuple index x not in list. So when you try to access an element which doesn't exist in a tuple, you will be getting an error there. So that is one specific thing you have there. So let me actually just clear this out. The differences, let me write the proper differences between tuple and a list there so that you can have a final, like we can wrap our session there. Here, first thing, you have list. Okay. And next, you have tuples. What do we know about this both these things then? So see, tuples are mutable and here immutable, immutable, immutable. Lists are mutable, tuples are immutable there. Syntax. Now, lists are created using square braces, tuples are created using parentheses there. And in case of performance there, these are slightly slower, slightly, slightly slower. These are faster, faster for fixed data. Now, use cases, there are different like different areas you can use list when you want to when you don't know how many elements you're going to have, and if you want to modify it, that's when you can use list. Tuples, when you have a fixed size of elements or you don't want to change any data or add any more data, then you can actually just use this tuple there. No. So choose tuple. Like my recommendation is that you choose tuple when your data is constant and doesn't need modification, and you use list for data that requires frequent updates there. So that is one example I can actually provide you. And one more thing is that you can also have nested tuples also there. It's not like you can only store numbers and the strings here, but you can also store different I like a same type of data also. One example within let's call the log 2. Now here within our tuple, I can have a different tuple there which is storing this coordinates. Let me actually grab this coordinates. That's the tuple. That is also possible. Now we can also have a one more thing there. One more tuple. Let me slightly changes this. Let's make it as 13 and let's actually make it as 20. So these are the different things you have there. So that is one specific example you have here there. Okay, you can also have nested tuples also there. No problem. You can also access it. Let's say if I say log of index value 1, for example, at the index value 1, you have this particular one. And if I execute this one, see, oh, you're getting an error because of the previous line. Let me comment it out, which is this one. If I execute this, see, you are getting that entire tuple back at that specific index. That is one example of these things there. So that's for the tuple section.
For more informative videos, do not forget to subscribe our Best IT Academy's YouTube channel.